Great to be at ADC again. Thanks to the entire ADC team for putting up this event. And a special shout out to Jim Rooper, who was very helpful in getting this talk on stage. I need to be reasonably brief, so I would have to assume that you are familiar with the basic concepts of ARA 2 as it is right now. And if I'm bringing up some details you're not familiar with, if you want to catch up on anything, obviously there's the ARA documentation, but I can also refer you to my talk at ADC 22 called 10 Things Every ARA Programmer Should Know, in case you need to catch up on any of the things I'm mentioning here. We usually don't do any of these sneak peeks. Instead, we try to provide working drafts and then open this for review when it's actually working. ARA 3 is way more like up in the clouds. It's not very concrete at this point in many ways. But the reason we're presenting is here that if you're doing such a big step in development, you really need to make sure that a lot of pieces interact together well. And you can't like really look at only the individual parts of it. You need to have the bigger picture. So we try to give you just that. What are the goals that we're trying to achieve? Well, before answering that, let's remember what is the main goal of ARA actually, like without looking at the version. And the core thing it's trying to address is this problem. You can't really make music the way that we usually do if you're tied to only the real time. And some of you might be wondering, well, what are you talking about? I've been using my VST instruments for decades to make music. Yeah, but if you think about what's actually happening when you're doing this, is that you, while you're playing these instruments, do have a lot of knowledge in your head and a lot of assumptions that you're relying on when doing so. You have an expected tempo. Your instrument's going to be tuned in one way. You're likely playing in a scale, and you have a chord progression or some sort of song structure. So there actually needs to be some level of knowledge about the composition, and this knowledge is required ahead of time. You can't tie this only to the real-time context. And this is where ARA comes in. It provides random access not only to the audio source material that you want to use in building your song, but also, very important, to the composition that you want to use this in. And this enables DSP algorithms that actually make musical decisions and not just look at the raw audio signal. This approach turned out to be very powerful, not just for Melodyne, but there's many other ARA plugins on the market right now. And it's adopted by the vast majority of the AWs at this point. And the success also comes with a lot of responsibility for us now to maintain and drive the standard further in a careful way that extends its power and versatility without breaking too many things along the way. So if we want to look at where we want to go, we first should check where we are. There's a lot of familiar faces in the audience. We are in touch with many ARA developers, and we know about the issues that they encounter with the current ARA thing. Number one request, just an example to give you, to describe the kind of problems that are in this category, is that you want to have persistent reach and sequence data. You want to be able to associate data with a track and save that with your song. That's going to come with ARA 3, and it's very clear what the way is going to be. It's going to work like all the other ARA persistent objects. You're going to have a persistent ID. It's also going to tie into the partial persistency, so you can copy a track from one song to another, and so on. But we needed to do this only in a major version increase because it's a change of the model in a non-backwards compatible way. But there's another set of problems, of use cases that are simply not covered by ARA 2. And this actually goes out like to the unfamiliar faces in this room. There are use cases that developers wanted to do where they've found out that ARA 2 just doesn't cut it. And what usually happens, these guys give up on ARA and they never talk to us, so we never are educated about what's actually going on. What is it that we would need to improve? And these guys usually also work in areas where we lack the knowledge. For example, raw MIDI data, that's something we are not working with at Ceremony. So please educate us. This is the main reason why we're presenting this here, to reach out to those people that have ideas about what ARA might do that we don't have yet. And obviously, we also want to keep talking to everybody who's already in the ARA 3 community, in the ARA 2 community, to make sure that this also works for ARA 3. What are the main use cases that we want to address? Well, one topic that has come up a lot lately is singing voice synthesis. And there are various applications available that provide this feature. I'm pointing out two of them because they are very interesting for the specific context of ARA 3. On the left-hand side, you're seeing synthesizer V by Trimtonics. And this is an ARA 2 plugin. This is an actually released plugin that's out on the market. And it helps us to understand very well what are like the quirky aspects. For example, you always have to have some dummy audio source, like some file that you're applying this on, even if you don't want to use that file, because it's a synthesizer. It's going to generate the voice. And then the other example we want to point out is Omnivocal, which has just been announced, I think, last week by Yamaha. And this is very tightly integrated into Cubase using custom internal APIs. And this provides a glimpse of what level of integration we should go for when designing ARA 3. Here's another use case that the vocal synthesis or other related algorithms, they would like have the notes as input. What about plugins that want to generate the notes, like the actual music? There aren't that many plugins out there. I have prepared, I hacked up together a demo to show what this might look like. And I've pre-recorded this in order not to crash the conference laptop.
We are starting out here with a composition. It's a lead sheet with chords, tempo map, song structure, and a beautiful vocal melody, in this case, written and performed by Nicole Milik. Now with this potential plugin, imagine that instead of recording your own guitar parts to accompany these vocals and build your song, you could go ahead and inside this plugin browse for, let's say, some acoustic guitar pattern that you really like and that fits your idea of the song. And once you've found that, you would drag this into the host. And just by itself, it sounds like this. So pretty simple, but very effective. Now you can drag out this pattern to play where you want it to. Let's say we want to cover this verse. And now the machinery inside the plugin goes ahead and rearranges the notes just like a guitar player would have played them. And this arrangement is still fully dynamic. So if I go ahead and, for example, change this chord right here, you can see that it would have rearranged the notes, in this case, creating this beautiful top line here, just like a musician would have done. And now with just a few clicks, you can have a song that sounds like this.
Sometimes I stare upon the city night, wondering what it would be like to see my name in neon lights.
So I said there's no plugin doing these kinds of things yet, but many of you are aware that there's the Logic Pro session players, which are kind of similar to this, but there's like no API to write your own session player or no way to write a host for plugins like that. So it's again, in terms of API, this is something that we want to address. And the main thing that both the vocal synthesis and these applications have in common is that you want to be a generator, right? This is not based on samples provided by the user. This is a generator that generates the content based on the musical ideas and descriptions that the user enters in the host UI. When this is going to be our core feature, what are the things that we need to be careful about when adding it? We should not muddy the waters in terms of how ARA is designed at its core, about the basic ideas. This all should just stay intact. We need to make sure that we are not like adding a bunch of things that are only usable for the generators and kind of neglect the existing like classic ARA plugins. And we need to limit the amount of changes that everybody has to do in order to adopt it to a workable amount, right? There's no point in building like the perfect API that nobody's going to adopt because it requires so much work. So let's look at our venerable ARA model graph shown at this conference a couple of times at this point. What is it that we need to change if we want to enable generators? Well, the playback side basically will remind us is we need a description of our composition, which is in the musical context. And we have basically areas of playback grouped by tracks. But the obvious change is on the input side, the audio source will no longer have samples, right? We just need abstract audio sources and instead rely on content that the host can provide for this audio source in order to control the synthesizer. But exchanging content on the audio source level is already part of the ARA API. With the classic sample-based plugins, you, for example, would read the tempo from the host and all these kind of things, or the host could use the plugin to perform a tempo and map analysis in the plugin. This is all there. The difference is now that with the generators, it becomes like the core thing. And there are likely different types of content that are going to be used there. And the content is going to be updated much more frequently. You still want to be able in your host to edit the notes and have the synthesizer follow. But still, in terms of the actual model graph, there are no changes required. We only need an API for the plugin to indicate that it can work as a generator, that it doesn't need audio samples as input. And it also should indicate to the host, like, what are the content types that we need to control the synthesis. So with the model like being already sort of compatible with everything, what about the playback rendering? Well, ARA renders the playback using like the VST and audio unit, AX, clap, whatever plugin instances. And these plugins will, when used as playback renderer, will ignore their real-time input. Because instead, they're going to look at the model, they're going to pull all the sample data that they need ahead of time through the model. So they already are generators. ARA playback renderers already are generators. We have no input at the real-time level. So again, no changes necessary here. So if we go back to our goals, to our mission statement if you want, we can achieve this like without any changes to the core design. It's just there. And this allows us to keep the scope of changes very, very narrow. But this is not to say that there's only a little change. There's going to be quite a few changes on the user interface side. We need to understand the workflows, the use cases, and we need, especially on the host side, to provide user interfaces that cater for these workflows. So what would the user interaction with such a generator look like? For example, let's start out with a track where we want our generator to play a region sequence in terms of ARA terminology. And now, because this is an abstract source, we need to start with it from scratch. This is an empty container. This is our abstract audio source. It's empty in this case. It could be pre-populated by the host with, for example, MIDI data copied from another track or patterns from some library. And we also want to enable the plugin. You saw that in the second use case, in that pre-recorded video that I've shown, where the plugin actually provides some initial data for this. But it also needs to work with just an empty thing. And if I, let's say, want to do my single voice synthesis, I would now go ahead as a user, add my notes and my lyrics, and then add the plugin. And voila, it will sing the notes in some way. However, most of the plugins will allow the user to fine-tune the results beyond just providing the notes. Let's, for example, assume that you can add a vibrato curve to the given note. Now, the interesting question is what happens if you actually go ahead and in the host change that note? Our data is now no longer associated with the given note, but we want to preserve these edits that have been done on the plugin side. In this case, you can sort of guess this from the amount of nodes on the position of nodes not being changing, but there are other edits possible in the host that will totally mess up any algorithm that tries to compare the previous state with the new state in order to map this. So in order to support this well, we need to add persistent and unique node IDs, so that the plugins have the option to attach any sort of custom data to the nodes. We want to limit this to the nodes only because we think that it's not easy to maintain persistent IDs across the entire application. But in this case, we think it's very important to have that feature because this is going to be the core input for many of these plugins. For the other data types, for example, for the lyrics, we still would resort to comparing the previous and the new state, because also we assume that there's not going to be as much attached data. This problem is not new to ARA, and it's not specific to generators. If you're currently using Melodyne and the host goes ahead and modifies the input sample data, then Melodyne again also will have to perform a new analysis of everything, and you're going to lose the user edits because our model graphs are so big and complex that comparing them is really hard. And also this use case doesn't happen as often. But for generators, this will be the very regular use case that you actually edit the audio source. But then on the bright side, the data that you need to compare is normalized content data, which is much easier to compare than anything analyzed from the audio samples. Another thing that we need to point out is that if we go back to this example, how long is this container actually? Well, there's no natural boundaries to it. It's not like I've recorded something, so the recording started and ended. It's just an abstract container, so I should be able to extend it, paste some more nodes into it, and I should be able to do the same at the front of this. This is surprising, but it's nothing actually so new to the ARA model, because for audio modifications, we already have this. You can go ahead and Melodyne, grab a node and copy it and then paste it way before the original start of the recorded material. And now it depends on the host. Only a few hosts do that, but you should be able to extend your playback region to start like before the original file started. And this is the same pattern that we're going to see for the generators. Another point and another topic worth pointing out is, what are we actually seeing on this host track? And usually it's the input data, right? Now, for the sake of illustrating this, let's assume our plugin has a built-in feature where we can add harmonies to the main lyrics. So for each node in the host, we now have 2 nodes. But in the host, you still just see this single node, which is normal. If you have an audio track and you're adding a delay on the track, you're not going to see the repetitions on the track. However, because this is nodes and this is a very abstract level of thinking about music, if you're actually arranging the other tracks, it would be very useful to know exactly what nodes are playing in this generator. So we would suggest that the host developers look into the possibility of, in addition to having this like established mode where you see the input data and you can edit this. I'm trying to use this little pencil to indicate that this is edible, to compare or to switch to another mode where you can see the output. And the output would be read-only. You couldn't modify the output in the host UI. You would need to go to the plugin UI in order to edit this. And again, let's compare to the existing ARA plugins. This is Melodyne running in Pro Tools, and Pro Tools does what many DAWs do these days. When you have an ARA plugin that outputs node information, then they would go ahead and on top of the input waveform that they usually draw these little nodes. But you can see here that is a bit of confusing because you're seeing the output nodes on top of the input waveform. So this node that has been stretched in Melodyne, I'm not sure if you can actually see that on the projector screen here. actually starts way before the waveform indicates it. And this fourth node has been deleted in Melodyne, but it's still there in the Pro Tools input display. We've been floating a draft for the host to query the output waveform of a plugin in order to fix that. I mean, the host could always go ahead and render the output and then do the waveform calculation based on that. But in Melodyne, we already have waveform here, right? Why don't we export this to the host so they don't need to spend all this performance on creating data that's already available? So this draft is again going to be considered to be part of ARA 3. And like all the topics that I'll be mentioning now so we are now back to this. These are little things that add up together, but they can be added independently because they are not changing the core structure, and then they don't require a major version increase in order to be added. Lyrics, obviously, we want to have this in the original ARA 3.0 because we want to address singing voice synthesis. But it's also not as trivial as it sounds first, because if you look at lyrics, there's actually different layers to it. You're starting out with the words, and then the words will be basically grouped into, split into syllables. The syllables kind of will define the timing with which you want the notes to be sung. And then you have the phonemes, which will affect the sound. And we are not sure yet like how many hosts are going to support which of these layers. This is all stuff that we need to find out. What we want to do with the lyrics, regardless of which of these three levels you're looking at, we want to sequence them in musical time, just like we currently do with the chords or with the key and bar signatures. So they would be independent of tempo, and they would be basically related to the quantized version of any note that actually would be singing these vocals. Because of that, they also would not be coupled directly to notes. The timing might be different, the micro timing, but also you could have multiple singers singing the same note with the same lyrics, but each of these notes will not align perfectly. So you have like 3 notes singing the same lyrics. And if this was coupled, you would be in trouble. Multiple lyrics happening concurrently is also a topic that we need to look into. How can we support like a duet or something like that? This is something we need to talk about in more detail with everybody interested in singing voice synthesis. Another issue we look into is, I've shown the example earlier where we would be attaching the vibrato curve to the note, but there may be other parameters in these synthesizers that you would much more naturally set in the playback domain, so basically on a track level, which the region sequences, aka tracks, are now going to be persistent, so you can actually do that. But wouldn't it be great if this data could be edited in the host just like you currently can with regular VST3 parameter automation, but we're doing our ARA, so can we have this and make it randomly accessible? There are a bunch of questions associated with that. If you remember Fabian's talk last year, if we have like data in the plugin that's opaque, but then you have the automation outside in the host, like which value is now who's the owner of the data, what's the single source of truth? Also, if there's curves and stuff like that, how do you model these curves across the API? We will talk about that. We will need to talk about that with the interested parties again. Another cool feature to have would be sidechains. You're all familiar with these piece algorithms that use sidechains. There's Vocaline, Autoline, all these ARA plugins on the market out there, and many other applications may be coming up. What happens there currently with ARA 2 is that you would need to insert your alignment plugin, for example, both on the source material and on the target track. And then inside your plugin, you would need to define like what is the reference and what is the target, which obscures the signal flow. You don't really know, like looking at your arrangement, you don't really know what's going on anymore. And also the a reference signal is piped through the entire rendering engine, and then just in order to bypass it, which is like not a very efficient way of using the CPU. And it also does not team up well with the use cases where you have generator plugins that have an audio input sidechain. So how could we potentially address this? We could make sidechains an explicit capability of the ARA plugin. The host could then go ahead, query this capability, provide the user with an interface to select the sidechain, probably on a region sequence, aka track level. And then once the user has selected this, all the host needs to do is for the objects on this track, create the ARA objects like it does already, and also update them in the same ways with the current use case. The only difference being that they would not have to add a renderer for the sidechain, because any access to this data would be done from the processor that actually uses the sidechain. And this allows for a couple of cool use cases. If you wire it up everything, this API would allow for your main vocals being like edited in Melodyne. And then the output data of Melodyne could be used as audio source for singing voice synthesis. And this could be combined with a harmony track in your host with the chords. And then this plugin could do this harmonic voice generation as an using the sidechain feature. So whenever you edit a note in your main vocals in Melodyne, it could adjust the choir or whatever it builds around that. And this is really cool, I think. Another feature that's been under discussion for a long time is the integration of undo and redo. I will not go into this too deeply, but the main problem is that if you have undo state in the plugin and in the host is controlling the model, you can have a change in the host that invalidates the data that the plugin has in its undo. It currently needs to delete the undo in this case. And then if you undo this according change in the host, you can't undo in the plugin anymore because you needed to delete this. So it would be much better to actually end up in a situation by this, where you don't have the undo menu in the plugin anymore. There's just one global main menu in the host for the undo and redo, and the plugin would integrate with this undo in the host by providing opaque sets of data and a title that you can attach to that, so you can have a proper naming in your undo menu. This is not trivial because all the DAWs have like slightly different approaches, and the plugins as well, and we need to find a common ground. There was a very interesting discussion about that in the CLAP community last year, I think. So if you go to their Discord, you can really learn a lot about like what are the actual setups for undos in the plugins and the hosts, and what are the problems if you want to interact like that. Topics like persistent versus transient undo and so on and so forth. So this is a good way to get into the topic if you like to. It's on their Discord. And the final thing I want to talk about today is enabling the out-of-process operation of ARA plugins. The API has been compatible with out-of-process operation from the get-go. It was one of the design goals when we originally did this. But in order to use this in practice, you have to channel, obviously, all the ARA calls through some inter-process communication. So what we've done in the last, over the last 2 years or something like that, if you've been following the ARA SDK, you can see all these changes. We built an extensive library that has proxies both on the host and on the plugin side to encapsulate all of that. So other than setting up the proxies, you can just keep all your ARA code as is. However, when you're actually running this, you will hit a conceptual problem with running plugins out of process, which is we have a main thread in the host, we have a main thread in the plugin. So if the plugin has UI, that is. So we have two main threads that can be run concurrently by the OS, frankly. And if these two main threads happen to interact and edit the same model, as is the case with ARA, you'll be in trouble. So we need some way of synchronizing these two threads, and I'm very open to any input that you guys might have how to achieve that. So with that, I'm going to end my brief rundown of the major things we are targeting for ARA 3. I'll be around after the presentation taking questions, and also in the spaceship Great Britain, there's going to be a booth where I'll be sitting when I'm not attending any talk, and I would be very happy to get in touch with all of you. So thank you for listening, and we're looking forward to your input and contributions to ARA 3.